Hi, everyone. So welcome back to class today. Today we did an activity called Climate Time Machine. And this was all about using models to understand the effects of climate change. So the warm-up question was on Google Classroom. This was lesson 32 warm-up. Yes, lesson 32 warm-up. The question is, what do you think would happen if the Earth got 10 degrees Fahrenheit warmer? This is a guessing or like a prediction kind of question. So it's your best guess is totally fine. For this question, please avoid using, or please use your own words and ideas, and please avoid using Google. So go ahead and answer that on your own. So today's agenda, we just did the warm-up. Next, we're going to read the Scientific Models article, and then we're going to explore Climate Time Machine models, the ones that I did not discuss earlier, but that's okay. And then lastly, we'll do our exit slip. So today's goals, by the end of today, you're going to be able to do two things. First, you're going to be able to use a model to evaluate changes as a result of climate change. You will also be able to analyze data for patterns. And then today's focus question is, how will climate change affect the stability of humans and the environment? So that's just basically saying, like, how is climate change going to affect us humans and our environment? Right? Cool. So really quickly, before we look at the Climate Time Machine models, we're going to talk about scientific models. So there's a little article that we read in class. I'll just read it to you right now. Developing, evaluating, and using models is a fundamental practice in science. Scientists use models to investigate objects or processes that happen too slowly, too quickly, or on too small of a scale to observe directly. They also use models to explore phenomena that are too vast, too complex, or too dangerous to study firsthand. Scientists use different types of models depending on the question they're investigating. So one important thing from this paragraph is that scientists use models anytime the thing we're studying is too big or too small, or just it happens too slowly, too quickly, or it's just far too complicated for us to understand directly without using a model. In science, a model is any representation of an object or process. Pictures, diagrams, computer simulations, mathematical equations, graphs, and human models are all examples of scientific models. To figure out the future of climate change, scientists need tools to measure how Earth responds to change. Some of these tools are global climate models. Using models, scientists can better understand how Earth works and how it will react to change in the future. So models help us understand how the Earth is going to change, especially when we talk about climate change. Global climate models use math, a lot of math, to describe how the atmosphere, the ocean, the land, living things, ice, and energy from the sun affect each other and Earth's climate. Thousands of climate researchers use global climate models to better understand how global changes, such as increasing greenhouse gases or decreasing Arctic sea ice, will affect Earth. The models are used to look hundreds of years into the future so that we can predict how our planet's climate will likely change. So one important thing, models use a bunch of different, they use data from a bunch of different processes on Earth. So things like the atmosphere, the ocean, the land, living things, ice, and energy from the sun. It's all very complicated. And they use all of that to make global climate models. There are various types of climate models. Some focus on certain things that affect climate, such as the atmosphere or the oceans. Models that look at a few variables of the climate system may be simple enough to run on any computer. Other models take into account many factors of the atmosphere, biosphere, geosphere, hydrosphere, and cryosphere, the frozen part of Earth, to model the entire Earth system. They take into account the interactions and feedbacks between these different parts of the planet. So in this paragraph, they talked about the four spheres of the carbon cycle: the atmosphere, the biosphere, the geosphere, and the hydrosphere, but they also mentioned the cryosphere, which is a very important, minor sphere. It's very important to understanding climate change. The cryosphere is all of the ice on Earth. So technically, the cryosphere is part of the hydrosphere. But when we talk about climate change, it's useful to think of the cryosphere as something separate. Throughout this unit, you will be looking at several different models to explain climate change. Some of these models will be computer simulations, and others will be graphs and data sets. Both types are important to understanding the cause and impact of climate change. So, with that said, we are going to take a look at the climate time machine. So if you go on Google Classroom, there's going to be a post called Lesson 32, Climate Time Machine Activity. In that post, there is a Google form. When you open the Google form, it looks like this. At the top, it says sea ice. A little bit towards the middle, there's a screenshot that says Climate Time Machine. What we're going to do, we're going to look at 4 different models to understand how different aspects of Earth's climate are changing over time. So the first 2 models we're going to do together, or rather I'm going to do for you, but then the last 2 you're going to do by yourself. So to get to the models, you're going to click on this website at the very top, and it's going to take you to a screen that looks like this. All right, so the first model we're going to look at is sea ice. So we're going to click on sea ice, and what we see is the Earth. This is the North Pole. So all this white stuff here, this is actually ice. And right now you can see that the ice kind of extends, actually in 1979, you can see that the ice extends from Greenland all the way to Russia and almost to Alaska. And when I press the play button, we're going to see how the amount of ice changes between the years 1979 and 2020. Okay, so we can see that the ice has changed a lot since 1979. So in 1979, it was pretty big, and in 2020, it's pretty small. Of course, as time went on, it got bigger, it got smaller, and then it got bigger, and then it got smaller, and then it got bigger, but generally it just got smaller. So back to the Google form. Question 1 says, is the information shown about Arctic ice actual data or a model of potential data? So actual data means things that actually happened, whereas potential data means something that hasn't happened yet but could. This model of sea ice went from 1979 to 2020. This is what actually happened. So this is actual data. 2, what happens to the image as the data moves? Like I said, the ice gets smaller and bigger, but generally it gets smaller. The ice gets smaller and bigger, but generally speaking, it gets smaller. Number 3, what factors might influence this happening? So you guys know that because of increased carbon dioxide in the atmosphere, the Earth's climate is warming. And as the Earth's temperature warms, ice is going to melt. So we know, or we think, this is happening as a result of rising temperatures on Earth. This is happening as a result of rising temperatures on Earth. Number 4, what questions do you have about this information? Or did anything spark your interest? For number 4, go ahead and write any questions you have about anything you saw in the model. I'll be sure to answer your questions in the upcoming classes. So when you're done, go ahead and click Next, and then we will do the second climate time machine model, which is sea level. So if we return to our climate time machine, and by the way, this website was made by NASA. It's quite nice. And all this data is coming from NASA or labs that NASA works with. But anyway, back on this website, if you go in the top right, you're going to click on sea level. And you're going to see a map that looks like this. So we've got, this is the southeast United States. We've got Florida with Miami right there. And over here we have Louisiana with New Orleans right there. You can't really see it. It's difficult to tell, but there are little red dots. All of those red dots represent areas of land that are underwater as a result of rising sea levels. So in this model, we're going to see how the land would change as the sea levels rise from 0 meters. That's just 0 meters today, all the way up to 6 meters. So a meter has about 3 feet. So 6 meters is that's about 18 feet. So we'll see what happens as the sea level rises. All right, so you can see, like not half, but like a third of Florida is underwater. All of New Orleans is underwater, and all these islands over here underwater. Just a lot of land has disappeared as a result of rising sea levels. So 6 meters, that's 18 feet. That's quite a bit for the sea level to rise. In like the next 10 years, I think like maybe. Actually, I don't know. I'd say like in the next 10 years, probably like 1 meter is like reasonable. No, even that's quite a bit. But, well, anyway, 6 meters, it's going to take some time for us to reach 6 meters. And hopefully we never do. Hopefully we solve climate change by then. And that's because, this isn't just a problem that New Orleans and Miami are going to face. It's the same thing in Northern Europe. A lot of Europe's underwater. Same thing in the Amazon. Large chunks of Brazil are underwater. And same thing in Southeast Asia. Although these mountain islands are probably mostly pretty safe. Yeah, so this is pretty serious. So let's return to sea ice, or rather to the Climate Time Machine Google form. Number 5 says is the information shown about sea level actual data or a model of potential data? This model is showing what could happen, so this is actually potential data. Number 6, what happens as the sea level rise increases from 1 meter to 6 meters? Like the land on the coast goes underwater. Number 7, what do you predict will happen in the next 10 years? I'm going to leave that up to you. It's your prediction. I guess, and honestly, I don't know. I haven't looked at data for rising sea levels, but I'm guessing probably in 10 years, maybe like a meter is reasonable. So 10 years from now, it could look like this, but that would put New Orleans mostly underwater. But anyway, you just tell me whatever you think is reasonable. It's your prediction, so whatever you write is totally fine. And again, number 8, what questions do you have about this information? Just give me your best, or just let me know if there's anything you don't understand that you want me to answer in our upcoming classes. All right, and before we move on, there's one thing I want to show you. So rising sea levels is going to be a very serious problem, and the New York Times actually has an article that gives us a much better picture of what rising sea levels could look like by 2050. So they've got a couple different countries shown here, but for each projection, they show what we used to think the sea levels would be like in 2050 and what we now think the sea levels would be like in 2050. So I just wanted to show you Vietnam because right now we think this is going to be Vietnam in 2050. All this blue stuff, that's land that's underwater. Well, all this like darker blue stuff, that's land that's underwater. So as you can see, like half of Vietnam just gone, just completely underwater. And I'm showing you this so that you understand like this is going to be a very dire problem. There are a lot of people that live here, and there are a lot of cities here. And it's not just Vietnam; it's other places like Thailand and China, India. But anyway, I just wanted to show you that very quickly. So now what you're going to do, you're going to click Next, and you are going to do carbon dioxide and global temperature by yourself. Just a reminder, to get to carbon dioxide, click on this one in the top right, and to get to global temperature, click on this one in the top right. When you're done with the Climate Time Machine activity, there is an exit slip. It's called Lesson 31 Exit Slip. The question is, why do we use global climate models? So for this question, please use your own words and ideas and avoid using Google. All right, that's all I have for today. Please let me know if you have any questions, and I'll see you next time.